Algebra II, 4.4b. This is part 1. 4.4c is going to be part 2 of this video. You need to watch both of them. We're going to talk about how to solve a system in 3 variables, x, y, and z. And if you haven't seen the previous videos for chapter 4, you're going to get confused. We have 4.1 and 4.2a, b, c, and d, and 4.4a. They talk about a system in 2 equations. We can't solve a system of equations in 3 variables by graphing because they'd have to be graphed on a three-dimensional plane. And linear combinations followed by substitution is a practical way for solving the system of equations. Now we're going to need a lot of room for our math. You might need a whole sheet of school paper or even a half sheet of school paper just to do one of these problems, so be prepared. Now, it would be graphed on a plane that would look like this, and that's why we have to use elimination and substitution. That's why graphing can't solve this. We can't find one of these things that I made for every single problem in our homework. Can you imagine having to make one of these for each problem? That takes too much time. So it makes much more sense to use elimination and substitution. So we have this system of 3 equations, and there's 3 variables, and I've colored them green with the circle, blue with the square, and red with the triangle. Now, basically, what we're going to do is this. We've got these 3 equations, and we need to figure out what color is the circle, what color is the square, and what color is the triangle. So what we're going to do is we're going to add the green and blue one together to eliminate the circle, and we're going to get a new blue equation. Then we're going to add the green one to the red one. So see how the green one got dispersed to the blue one and then to the red one in 2 different addition problems? And then we eliminated the circle, see? Then what we did was we have this new blue one and this new red one, and we eliminated the square and found out that the red one was the triangle. Then we plug the red triangle into this new blue equation to find out that the square is blue. Then we plug in the red triangle and the blue square into the original green equation to find out that the circle is green. So basically what we're doing is using the first one and the second one together to eliminate a variable, then using the first one and the third one together to eliminate that same variable, then we're using the new versions of the second and third equation to eliminate another variable to find out what the third one is. See that? And then we're going to end up with our ordered triple. So let's see how this works. Now this could get confusing, all right? So I'm making a part 2 to this to do it again in a little bit different way. So the first thing we're going to do is use these 2 equations together to eliminate this x. We need to create a 0 pair. So I know there's a 0 pair here, but I want to start up here so that you can see how I'm doing this. So in order to create a 0 pair, one of these equations needs to be multiplied by a -1 so we can have a negative x, right? So let's do it to the green one. So we're going to multiply that green equation by a -1, and then we're going to add it to the blue one to create that 0 pair and eliminate that x, all right? So we distribute that -1 into every term, including that 4 back here. And we get -x minus y minus 2 equals a -4. Now when we add it to that blue equation, we eliminate the x, and we have a new blue square equation of -3y minus 2z equals -3. Now we're never going to see this version again. From now on, this is the blue equation, okay? We're keeping this guy. He's our new one. Now we need to eliminate x from the red triangle equation by multiplying the green one by a -2 and adding it to the red one. So now we're going back to these. We're ignoring the blue one because we've got a new blue one. So now we're going to use this original green guy, multiply him by a -2 so that we create a 0 pair with that +2. See? So we multiply each term of the green equation by that -2, distribute it in, including the 4, and we get -2x minus 2y minus 2z equals -8. Now, when we add it to that red triangle equation, we create a 0 pair with the -2x, +2x, and our new red equation, we'll never see this guy again. This is our new red equation, is negative 3y minus 4z equals negative 9. So now we've got this for our blue equation and this for our red equation. We'll never see those original ones again, but we're hanging on to that original green one, okay? All right, so now we need to eliminate another variable. So we're going to eliminate y from the new red equation by multiplying the new blue one by a negative 1. So we're going to multiply this guy by a negative 1 and change this negative 3y into a positive, because two negatives make a positive. And then that positive 3y and that negative 3y in this red one will create a 0 pair. All right? So we're going to multiply each term by negative 1, including this negative 3, and we get 3y plus 2z equals 3. That's kind of temporary for the blue guy, all right? When we multiply them by the negative 1, I want you to remember that this is still the blue equation with the negative 3y. This is just temporary to get rid of the y. Now that it looks like this, we can add it to our new red equation of negative 3y minus 4z equals negative 9. See? And this creates a 0 pair here. And positive 2z and negative 4z added together makes a negative 2z. This makes a negative 6. We can divide each side by that coefficient negative 2 and get z equals 3. So we solved this red one for z. Now we know what z is. It's a 3. Now we can use substitution to solve for the other variables. We substitute 3 for z in that new blue equation. Negative 3y minus 2z equals negative 3. We're going to put the 3 in place of the z there. So we multiply these together and we get negative 3y minus 6 equals a negative 3. We can add 6 to each side with the addition property to create a 0 pair here and eliminate this. And we're left with negative 3y equals negative 3. We divide each side by the coefficient negative 3, and we get that y equals a negative 1. Well, now we know what z is, and now we know what y is. We can plug that into the original green equation and solve for the green x. So we substitute the negative 1 for y and the 3 for z in our original green equation, and we get x plus 2 equals 4. We combine these. Negative 1 plus 3 is a positive 2, isn't it? So now we have x plus 2 equals 4. We can subtract 2 from each side of the equation with the addition property to isolate the x, and we get x equals 2. So now we know our ordered triple is a 2, a negative 1, and a 3. See? We can check by substituting the ordered triple into each equation, each of the original equations, to see if it makes all of these true. All right? So one more time, what we did was we took the first two equations and eliminated a variable. Then we took the first one and the third one and eliminated the same variable. Then we took the new version of the second and third equations and eliminated to find the last variable. We substituted that into that new second equation to find out what the second variable was. And we substituted these two values into the original first equation and got our ordered triple. All right? We're going to do this one more time with a slightly different problem, and that's going to be 4.4c, part 2. So it's really important you watch both parts, okay? Especially if you're confused. And if you're really confused, you should go back to watching 4.1 and then continue to this video in order, okay? So they'll be in the Algebra II playlist, and they'll also be in the description of this video. And I'm going to put the Algebra I Chapter 8 playlist for systems of equations. All right? And I'll see you next video. We'll continue this conversation, and we'll keep talking about how to eliminate and substitute when we've got 3 variables in a system. See ya. Bye.